Okay, geographers. This is going to be a short, basic video here. You can see I have our program opened up. Let's just go ahead and open up a new map. And we'll just call it, I'm going to call it projection. Yeah, I'll leave it as that and hit OK. And so all I want to do in this little video is show you how you go about changing the projection / coordinate system within ArcGIS. All right, and I'll get into the differences between those two terms here. It can be kind of confusing depending on where you first start learning these, but Esri decided to refer to things as coordinate systems, but they lump projections in there, and I'll point that out. All right, the first thing I'm going to do, and maybe I should explain too. Let me start here. We're not going to add any data. We're not going to make anything based on this video. I just want to show you where to go to change this. So it's just a standalone little video. I'll point out a few things, and then in the next video that I'll have for you, I assume there'll only be one more for this week of the class, but of course, check Canvas. I'll be clear with that stuff. You're either going to see one more video or 8 more or whatever it is. All right, but in the other video, you'll have an actual exercise. You'll need to go in and change the projection / coordinate system, but this is simply a how to do it kind of thing. So what I'm going to do to make sure we can see this, oops, the wrong way, I'm going to zoom out to the entire world here. All right, so we can see all of our continents and everything on the screen itself. And look, this is hideous. I'm not going to lie. This does not look proper. Now, you might look at this. What are you talking about? This looks like Google Maps or anything else I've seen. What's wrong with it? Well, it gets into that whole idea of a projection. How we take the round-ish planet Earth and we lay it flat. In this case, on the screen, but also on a sheet of paper. All right? That's a trick. That's this whole map projection idea. So this specific one, it's a Mercator projection. And I'm not dwelling too much on the exact names here. I'll give you some readings that give you some examples of some of the bigger ones. But this Mercator projection, it's an incredibly old one. It's useful for certain things. In fact, if you've read through my brief little descriptions on major and minor properties of projections and what's maintained and what isn't, this map is an example of conformality, right? Meaning that angles and shapes are preserved. But because this is one of those major properties, while shapes look good, size is totally screwed up. And that's the case with something like Greenland up here. This is way too big. If I continue to zoom out, I guess they crop it a little bit, but Antarctica, in just the raw projection, Antarctica goes on forever. So it's not good in that regard. This would be very useful. Let's say I want to sail across the Atlantic Ocean. Hey, fantastic. I'll use this specific map. And the way this one looks will work for what I'm trying to accomplish. But maybe I'm not doing that, right? Maybe I want to change it. So in order to do this, what I'm going to do is come up here to my contents pane, and this little area where it says map. I'm going to right click on that, go to properties, and I'm going to go to coordinate systems. Actually, before I do that, let's do this just to make it a little clearer. If I do black, just so you kind of see where the map begins and ends and all of that. So, okay. So that works. And you can do this if you want, or don't have to do it. You're not turning anything in here. We're learning. All right. So from here, right click, properties. I'm going to go to coordinate systems. And so when Esri, or ESRI, refers to coordinate systems, they also mean projections. Right? They lump this stuff in together with all of this. So don't get too hung up on it. It's not going to be a big issue for this class at all. But I tend to say projection because that's what I'm talking about. They use the term coordinate system, even though they really should have used projections. But that's just me. So in here, in fact, let me see. Yeah, I can stretch this out. When you come in here, got a few things. We have this favorites, I don't know what you call it, menu, header, whatever. I have a few things saved in here just to make life easier. And in this case, with this computer, I tend to not put too many in here, simply because I'm using it for teaching. When I was working just in straight industry and had to do the same kind of jobs over and over and over, I had this filled with some key coordinate system projection files here, so it was just easy to access. You are free to do this, and with any of these, well, I'll show you when we get there how to do this stuff. But that's the favorite one. Yours should, I assume, be empty at this point in time. Then we have this layers option, and this is referring to the layers in my contents pane over there on the left of the screen. All right, so it's saying this is what these are being projected in, the coordinate systems that they're using. So it's this WGS 1984 Web Mercator. In this WGS 1984, and like up here, this NAD or NAD 1927, these are what we call datums, horizontal datums, and they're starting points for coordinate systems. So this is the thing where all this kind of blurs together here. We're not going to worry too much about these in here. I tend to really stress this stuff when I'm teaching classes that aren't necessarily all GIS, but it's more map interpretation, using GPS for field methods and all that. They are important for when we're working with maps, but for what we're doing in here, we're not going to get overwhelmed with this stuff. So if you're planning on moving forward with GIS, I'll say you should absolutely know all of this stuff in here, but that's a little more advanced from what we're just trying to make some nice maps, right? Do a little analysis. We're not going to dwell on this stuff, at least not yet in this class. Okay, so yeah, so this other one, this is the existing layers. This is the Mercator thing we're looking at. But then we have these two. These are all of the different coordinate systems that are preloaded in ArcGIS. All right, so we have this geographic one, and if I open it up, we've got a bunch of stuff here. And I'll say this: don't use geographic ever. You're not going to need it. There's a reason for it. Apparently, I don't know. It's nothing we're going to worry about. And the long and short of it, they just look awful. So it's, if nothing else, it's going to make your map look horrendous. So don't worry about those. Instead, we're going to focus on projected coordinate systems. All right, so we open this up. We've got all these other little subfolders in here. Make this a little bigger. Handful of things. I encourage you to explore these, and it's stuff like it kind of, sounds like you're right. Continental, referring to a specific continent. So if I'm making a map of the United States, I might pick this North America one, and I'll look in here and pick something. And in fact, I think it's next week we'll do this. We'll build on this, and we'll play around in this continental folder. All right, and it's same thing. If like that South America map we made, that first map that we did, I didn't have you do any of this stuff, but if you wanted to go back, make sure it looked just as good as it possibly could. Well, we have three options in here where it's specific to South America. When I'm not zoomed out to the entire world, but I'm focused on that continent, either of any of these three would work well. All right, but we're looking at the world right now. So we're going to, well, we have two options, right? Sphere-based, ignore it. Is the Earth a sphere? No. That would mean it's this perfectly round thing. No, we are funky. And there are a bunch of different terms. Again, this is stuff I'd get into in other classes. We're technically a geoid. You also see the term spheroid, ellipsoid, oblate spheroid, oblate ellipsoid. We're not a sphere. All right, so we're not going to worry about that. We're going to instead just go into the plane world one here. All right, and we have all of these possibilities. These are all different ways in which the entire world has been projected. All right, let's see. So we've got this Mercator one right here. As I said, that's conformality, good for angles, good for navigation. This sinusoidal, let's use this one, I'll hit OK. This would be one that maintains equivalence. Right? So it's maintaining size. Angles can get screwed up, but size is maintained. And this is interesting, this weird nothingness over here. And this is, I don't have actual data. Oh, there we go. It just was taking a while. I don't have actual data in here. This is just this base map, right? And if I were really trying to do a nice map of the world and get into this stuff, I'd be bringing in, well, like we did with the South America stuff, different feature classes, make it look sharp. But this at least gives you the idea. And what we can tell with this, like Greenland, okay, up here, this is a good clue when you're dealing with these different projections. Greenland, in reality, is effectively the same size as Mexico. So if I'm looking at a map of the world and I see that Greenland and Mexico are the same size, generally speaking, okay, I know that my equivalence is set size, right? That previous one we had, the Mercator one, Greenland was gigantic, right? So in that case, size was terrible. You follow? Okay, that's the idea. And so a handful of these can be useful for maintaining equivalence or maintaining conformality. Sometimes it gives you clues in here as to what it's showing. Other times, not so much. But with all of these, what you can do is look it up, right? Just Google the name, like this one, Malweide. It's a German thing, looks like moleweed or whatever. If you're interested in that one, in fact, let's just click it. And if you can see here too, that little star, add to favorites if you wanted to. But I hit OK, and it changes. It's kind of a cool oval shaped thing. But if I get that, and I'm like, oh, that looks cool, but I have no idea what it's doing, right? Well, number one, you could do things like check Greenland, Mexico, get a sense of what's maintained, what isn't, but Google it, put the name in there, and do Malweide properties or something along those lines. See what you get, right? To know, is this the best map or the best projection for the map I'm trying to produce, right? For the effect I'm going for the analysis I'm doing, or whatever, okay? And this, just so you know, I double-clicked, left-clicked on map, got right back here, right? Same thing as right-click and going to properties. So, there's that. And then also, let me just show there's some of these, like Robinson is a great one. I'm going to hit OK. Robinson's projection is what we would technically call a compromise projection, in that it does not maintain perfect conformality or perfect equivalence. There's a little error on either side. It kind of meets in the middle. This would be an excellent choice if you're simply trying to depict the Earth in its entirety in a pleasant way. You're not using it for, aerial analysis. The example I think I have of measuring glacial ice or something like that, right? All over the world. You wouldn't use this for that. I wouldn't use this if I'm sailing across the Atlantic, because it doesn't maintain that proper conformality. But it's a nice representation of everything. So maybe I want to depict some things, point out some stuff about different countries of the world. It's not totally connected to shape or size or whatever. This would be a good choice. It's going to be an attractive choice. A little closer here. It's just a good way to depict the world. All right, so play around with these. look through. This is really all it is. And it's a case where there's never, the one right way to do it or wrong way to do it or whatever. You just want to make sure you're using the proper uh, um, projection / coordinate system here for the task at hand. And some of these, let's do this one. This one's kind of cool. The Spillhouse. Let's see if it's, I might have pushed it. Did I break you? Oh yeah, it's thinking. Oh, it's struggling now. There's that base map thing. Okay, that's not good. Here we go. Let it think. Oh, maybe I should turn off that hill shade. See if I click it. This is something you can see down to the right here. Got that little spinning thing going on. That means it's working. All right. If you ever click, in fact, I don't even know. Does it still do that? It doesn't seem to do it. It used to be you'd click and it would pause stuff. Now it's just going. Oh, good Lord. This is not good. Oh, I broke it. Okay, well, I tell you what, this is an excellent end to, no, don't identify. Come on. Come on. Let me turn this off. All right, let's get out of Spillhouse. Yeah, and this is why, too, we always save if there's ever something we're trying to do here. Just in case we break it. Well, the hell with this. I'm not going to wait for this. Luckily, I got cocky at the end. Started getting some of the fancier ones. You've seen it. All right, so best of luck. Be patient with your computer, with the data themselves that you're using here, but you get the idea. So here's this little resource for you, and this will hopefully help, not just with the exercise you do this week, but in future classes. I'll always be ensuring that you use the proper coordinate system / projection. For whatever it is we're doing, if you ever get stuck with that, you can come back here. All right, geographers? All right. Happy mapping.